All right, y'all, so today we're going to talk about factoring binomials, which we have done a little bit, but only just taking a GCF out and writing what's left. We haven't actually gone into the whole factoring process on these. So the good news is when you are having to factor a binomial, if it is not a difference of squares, we're not going to be able to factor it. And there's a really easy way to factor something called a difference of squares. We're not even going to do all of these notes. We're going to skip a lot, so it won't take very long. So if you look at number 1, okay, so this says x squared minus 9. So to be able to factor a binomial, okay, remember we still need to look for a GCF on every factoring problem. So on number 1, and I'm going to look, is there a GCF? No, there is no GCF. Okay, so if you see a binomial, the very first question you're going to ask yourself every single time is it a difference of squares? Okay, so let's talk about what that means. So what does the word difference mean? Okay, well difference means to subtract. So up here where it says difference of squares, that means to subtract. Okay, so these two squares are going to have to be subtracted. Okay. The only really confusing part of this is that you have to know your perfect squares. And it doesn't say that anywhere on here, but you have to know what a perfect square is. I'm just going to add a page before here, so you might want to just find an empty spot to list some of your perfect squares. Okay, so a perfect square is made by doing a number times itself. So 1 times 1 is 1. That's the very first perfect square. 2 times 2 is 4. So 4 is a perfect square. 3 times 3 is 9. The next one, 4 times 4 is 16. And the next perfect square, 5 times 5 is 25. Okay, so I'm just going to list these all the way to 100 because you're going to want to have these memorized. You're going to need to know what all these perfect squares are. So the next one after 36 would be 49 because that's 7 times 7. The next one after 49 would be 64, because that's 8 times 8. The next one, 9 times 9 is 81, and then 10 times 10 is 100. So obviously there's a million more perfect squares, but these are the main ones that you're going to be concerned with. Okay, so you have to be able to recognize those numbers. So let's look at number 1. So what we're first going to do is we're going to see, okay, is there a GCF? So no, there is no GCF. The next step is we're going to notice that this is a binomial, 2 terms. The only way that y'all know to factor 2 terms is now going to be difference of squares. So if we give you a difference or a binomial to factor on the test, it will be a difference of squares. Okay, and I'll remind y'all of that before the test when we review. All right, so here's what the trick is. Okay, so I'm first going to check, is this a difference? And if you see that minus sign, that's telling me this is a difference, okay? So that's check mark number 1. Now we have to check to see if both of these numbers are perfect squares, or if both of our terms are perfect squares, all right? So I look at x squared. Is that a perfect square? Yes, it is, okay? Because x times x times itself made x squared. So that makes it a perfect square. Okay, is 9 a perfect square? Yes, that was one of the numbers we just listed on the slide before. So, x squared is a perfect square, 9 is a perfect square, and it is a difference. Therefore, this is called a difference of squares. So, what's nice about these is if it is a difference of squares, our answers are always going to look the same. So, we're still going to have our 2 binomial factors like we have on the previous days. One is always going to be plus, one is always going to be minus. One's plus, one's minus. It doesn't matter what order they're in, but you got to have one of each. All right, so now here's what we're going to think about. Looking at the x squared. How was x squared made? What times itself got me x squared? X times x. That got me x squared. So I'm going to put an x at the beginning of both of those groups. Now I'm going to look at the 9. What times itself gets me 9? 3. So we have x plus 3, x minus 3. So what happens is on the last test, if y'all were given x plus 3x minus 3 to FOIL, what you would have seen was the outside and the inside cancel out. That's where x squared minus 9 comes from. Okay, if you didn't quite get that on the first one, that's okay. We're going to do quite a few. Okay, let's look at number 2. So again, I first have to check for a GCF, and y'all, you have to remind yourselves of that or else you're going to forget, I promise. Okay, so there is no GCF on number 2. Now I'm going to check, okay, this is a binomial, it's 2 terms. So now I'm going to ask myself, is this a difference of squares? And it is. Okay, first of all, it's a difference. That's easy to tell because it's a minus. Is z squared a perfect square? Yes. Is 81 a perfect square? Yes. If you look at the slide before, 81 was one of the numbers that we wrote down. All right, so now that I have decided it is a difference of squares, I'm going to make my 2 groups. One's going to be plus, one's going to be minus. Again, it does not matter the order of those. Now I'm going to look at my z squared. What times itself gets me z squared? Z. So z times z gets me z squared. Now I'm going to look at my 81. What times itself gets me 81? 9. And that's my answer. So if it is a difference of squares, you can factor it very easily, just like this. Okay? And if at any point you don't understand something, y'all, you're watching a video, so you can definitely rewind and rewatch it. All right, number 3. First, I'm going to look for a GCF, and there's nothing that goes into both 16 and 9. So now I see that this is a binomial. If this can be factored, the only way I can factor it is if it is a difference of squares. All right, so let's check this. Every single thing has to be a perfect square here. So is 16 a perfect square? Yes, if you look at the slide before, 16 was a perfect square. Is x squared a perfect square? Yes. Is 9 a perfect square? Yes. So if it is, and it is a difference, then it is called a difference of squares. So now we can go ahead and write our answer. So one is plus, one is minus. So this one's just a little different from the others because I have a number in front of my variable. So you first start with the 16. What times itself gets you 16? 4. So I'm going to put a 4 at the beginning. Okay, what times itself gets me x squared? X. Now I'm going to look at the 9. What times itself gets me 9? 3. So I have 4x plus 3, 4x minus 3. All right, number 4. Remember, we have to check for a GCF. Is there a GCF? Yes, there is. 4 goes into both of these. So I have to take a 4 out first, and then I have to write down what's left. So 4 divided by 4 is 1, minus 16 divided by 4 is 4n squared. All right, now we looked at the 2 previous class periods that when you take a GCF out, you still have to see if what is left can be factored. Well, now that we have a binomial today, you are now going to check to see if this 1 minus 4n squared is a difference of squares. So let's check. Is 1 a perfect square? Yes. Is 4 a perfect square? Yes. Is n squared a perfect square? Yes. And the minus tells me it's a difference. So this is considered to be a difference of squares. Now that 4 that we took out, remember we talked about this the other day, that is just going to be part of our answer. So if you want to just go ahead and write that as part of your answer, it's going to be there at the end. Okay, so now that we've decided this is a difference of squares, I can now write my final 2 factors here. So remember, one's going to be plus, one's going to be minus. Now what times itself gets me 1? Well, that's just 1. What times itself gets me 4? 2. And what times itself gets me n squared? 10. So notice here, I have 3 different factors, not just 2, because we had to take that GCF out from the beginning. Okay, this next one I'm just going to do, if you want to pause this and try to do those 3 problems and then watch me do it, then you can do that. If you just want to work it with me, then you can do that too. Okay, so first I'm checking for a GCF. There is no GCF. Now I see there's two terms. If there's two terms, I am asking myself, is it a difference of squares? So I'm going to check it. So is x squared a perfect square? Yes. Is 100 a perfect square? Yes. And the minus tells me it's a difference. So that's good news because this is going to be easily factored. I know one is plus and one is minus. What times itself gets me x squared? X. What times itself gets me 100? 10. So x plus 10, x minus 10. Okay, number 2, is there a GCF? I don't think there's anything that goes into 49 and 25. Okay, so I now notice this is a binomial, so I'm going to ask myself, is it a difference of squares? So I'm going to check it. So is 49 a perfect square? Yes. Is y squared a perfect square? Yes. Minus tells me it's a difference. 25 is a perfect square. So that means I can go ahead and write my two factors. So one's plus, one's minus, I know that. What times itself gets me 49? 7. What times itself gets me y squared? Y, so that's 7 y's. And then what times itself gets me 25? 5. 7y plus 5, 7y minus 5. And number 3, looking for a GCF. There isn't a GCF. So now I'm going to check for a difference of squares. C squared is a perfect square. Minus tells me it's a difference. 9 is a perfect square. D squared is a perfect square. So everything works. One's plus, one's minus. Again, it does not matter what order those go in. For some reason I always do plus and then minus. What times itself gets me c squared? C. What times itself gets me 9? 3. What times itself gets me d squared? D. C plus 3d, c minus 3d. Okay, this next part at the bottom, it's talking about perfect square trinomials. I'm actually not concerned that you are able to recognize those. If it is a trinomial, I want you factoring it like we learned last time, to where you do a times c adds up to b. I do not want you trying to look for some fancy shortcut because it's going to screw you up later. So I really just want you not to worry about that. So you can mark that out, and you can mark this next slide out because I am not concerned with you being able to know what that means. This next one is a grouping problem, and it's a special case. We will not give you any of those, so let's go ahead and mark that out also. Okay, so last week I gave y'all something that said the factoring flowchart. That is what this is explaining. I don't remember if it looks exactly like this, but it is similar to this. So I want to go through this because we're going to do a few factoring problems together just to make sure we remember how to do them all. Okay, so the first step for every factoring problem is GCF. Okay, so that's that first step. If there is a GCF, so yes, there is a GCF, we're going to factor it out. After you factor it out, you're going to look and see how many terms are there. If there are 4 terms, we're going to factor it. Okay, well, what does that mean? What does that mean to factor? Remember, we factor 4 terms by grouping. That is the process we use to factor 4 terms. All right, let's say there's not 4 terms. Let's say there's 3 terms. Okay, we did that last time. Remember the 3 terms, we actually had to break into 4 terms. So remember that's when we did our A times C adds up to B. And then you group. This is just kind of a review over everything. So that's, you find your A times C adds up to B, and then we broke it apart and we did our grouping. Okay, and then today we found out what happens if you have 2 terms. If you have 2 terms, you're going to ask yourself, is it a difference of squares? If it is, we are going to factor it. Okay, and how we did that today, remember we had the 2 groups, one was plus, one was minus. If you have 2 terms and it is not a difference of squares, then you are done. For example, if I were to give you x squared plus 9, is this considered to be a difference of squares? There is no GCF, Now if it's a binomial, I check, is it a difference of squares? Well, no, I can tell by that plus sign right there that this is not a difference. In that case, that would be my answer. There would be nothing else I could do to that. Okay, and then going back up to the top, if there is no GCF, then I just go to how many terms are there, and I go through this whole process. So you're going to have to know how to factor 4 terms, 3 terms, and 2 terms. Okay, so we're just going to do a few examples of those. All right, we're not going to do A because that one actually doesn't work out. So let's jump to B and C. All right, so going off of that flow chart, our first step is GCF. So what do all of these have in common? They all have 3R in common. So if I take 3R out, I'm now going to write out what's left. So I'm left with R squared minus 7R plus 10. Now that 3R that we took out, remember that is going to be part of our answer at the end, but for right now I'm done with that. And now we have this down to what y'all did last time, factoring a trinomial. So now we're going to multiply A times C. So I need 2 factors that multiply to be 10 and add to be negative 7. So I can tell right now if they need to multiply to be positive and add to be negative, it's going to have to be 2 negative numbers. And that these 2 numbers are negative 5 and negative 2. Those are the 2 numbers I'm going to use. All right, so this negative 7R, that's going to get broken down into a minus 5R and a minus 2R. Bring down your first term, which is R squared. Bring down your last term, which is plus 10. Now we just talked about on that flow chart, when you have 4 terms, the only way we know to factor is to group. So my first group has an R in common, that's my GCF. If I take that R out, I'm left with R minus 5. This second group has a 2 in common, but really it's a negative 2 because I had to bring that minus sign down. And so I am left with R minus 5. So remember how we write our answer here, what we have in our groups. That gets written down once, and they're the same, so we did it right. So we've got R minus 5, and then I'm going to write down what's left, which is R minus 2. And don't forget about that 3R that we took out from the very beginning. All right, let's look at C. This one's going to be much shorter because it's a binomial. So what's our first step? GCF. There is a GCF here. D squared. So if I take D squared out, that leaves me with 9D squared minus 2. Okay, so that D squared that we took out, that's part of our answer at the end, but for right now, I'm done with it. Now I'm left with a, whoops, that's not minus 2 up there, that's minus 4. I don't know why I put 2. There we go. All right, so now we're left with a binomial. So if you are left with 2 terms, you ask yourself, is this a difference of squares? Because if it is, you have to keep going. You cannot stop right there. That's not my answer. Okay, so I'm going to check this. Is 9 a perfect square? Yes. Is D squared a perfect square? Yes. Is it a difference? Yes. Is 4 a perfect square? Yes. So now, this has to be factored using that trick, that difference of squares trick. So 1's plus, 1's minus, I know that for sure. So what times itself gets me 9? 3. What times itself gets me D squared? D. What times itself gets me 4? 2. So one of my factors is that D squared that we took out from the very beginning. And then I have 3D plus 2 and 3D minus 2. Okay, these are just practice problems. If you want to practice these, I'm going to go ahead and just give you what your answer is. And so if you wanted to practice them, you can. But you do not have to. But if you want to practice, go for it. What I would just tell you here is that since this starts with a negative, you need to factor out a negative 2x before you even factor that trinomial. Okay, number 2, this is kind of like that last one we did with the difference of squares. If you want to work it, great. This is going to be your answer if you work it. So if you want to pause it and try to work these to see if you can get them, then do that. All right, last one we're going to do, just another practice problem, because we haven't practiced another 4-termer, or starting out with a 4-term at least. So first I look for a GCF. There is no GCF. So now I'm going to go straight into grouping, which I guess we did practice on another one, but we'll do this anyways. So if I look in that first group, they both have x squared. So if I factor that out, that leaves me with x plus 2. Now I'm going to look in my second group, and they have a 9 in common, but really that's a negative 9. And that leaves me with x plus 2. So my two factors here are x plus 2, sorry, and x squared minus 9. But we have a problem. I still have this squared here. And y'all haven't been taught this yet because today is the first day we learned about difference of squares. But if I still have something that's squared, I need to see if this can still be factored. Because there is a chance that it can be. So, can x squared minus 9, is that a difference of squares? Can it be factored? Okay, well I know it's a difference. Is x squared a perfect square? Yes. Is 9 a perfect square? Yes. Then this can be factored even more. So I'm still going to have this x plus 2 out front, but now this x squared minus 9, I can factor that down more. So x times x is x squared. I know one's plus and one's minus, and 3 times 3 is 9. And this is my answer. Okay, now let me tell you this real quick. If this would have come down to x plus 2 and x squared plus 9, you would now look at this binomial right here and ask yourself, is it a difference of squares? That is not a difference of squares. And if that's the case, that would be your answer. Okay, because that cannot be factored down anymore. But you always have to check to see if those squares can be factored anymore.